Subscribe to my channel and press bell icon for latest updates.
Hi, welcome to Learning Monkey. I am Raghuveer. In this class, we will discuss about our first data pre-processing technique, that is min-max scaling. So before going into the concept, first we have to understand what are the different types of data that we come across in ML. So the different types of data that we come across in ML are numerical data, categorical data and text data. Let's take an example and understand what these different types of data are. The example which we consider here is a housing price prediction data set. We already discussed about this data set in our first classes, so please watch those videos and come back here. So what these features are? Features in this data set are size of the house taken in square feet, location of the house and description of the house in at least 500 words given, and the cost of the house in lakhs. The size of the house is 1250 square feet, location is Bombay, description about the house, it's near to shopping mall, like that we can write some sentences here, and the cost of the house is 25 lakhs. So consider this size of the house in square feet. Our house may be 1250 square feet, 2000 square feet, 5000, 50,000. Based on the size of the house, these values are dependent, and these values are numerical values. This type of features we call it as numerical features. Coming to next one, location of the house. Suppose we collected this data on 5 different cities. Let's say Bombay, Delhi, Kolkata, Vijayawada and Chennai. These are the 5 cities which we collected this data. Then the location may be in Bombay, may be in Kolkata, may be in all these 5. The set of values, what's the set of values here? These 5 cities are the set of values. If you are having this set of values, then those type of values comes to categorical values. Okay, coming next, description of the house in words. Here we can give description in a paragraph. Like all the English sentences, we can use any type of English words we can use, and we can give a description about the house. This type of data comes to text data. Okay, you understand how many different types of data we come across with? Numerical data, categorical data and text data. In this class, we will understand about numerical data, what are the problems that we face using numerical data and how to solve them. This is what we discuss in this class. So let's take an example and understand what are the problems that we face using numerical data. Let's take 2 features. X is a feature and Y is a feature, and X is considered in kilometers and Y is considered in meters. The values are like this: 5 kilometers, 7 kilometers and 8 kilometers. Y is 5000 meters, 7000 meters and 8000 meters. If you do any comparison on these 2 features, let's take we are comparing these 2 features. 5 equal to 5000. This is the comparison which we consider here. Is 5 equal to 5000? No. But logically 5 kilometers, it's not 5 kilometers equal to 5000 meters, which is equal. But magnitude, by considering the magnitude means value. By considering the value, what it says, 5 not equal to 5000. So we are missing the essence here, the essence of units here. This is one of the problem which we face using numerical data. What's the problem? Considering the features in different units. Let's take one more example and understand some more problems which we face with the numerical problems. Age and sal. Age is given as 50, 59. Generally, employee age will be between 20 and 60. We start employment at 20 and we end employment at 60. Means the scale of these values between 20 and 60. Now consider the sal. Sal of the employees will be between 20,000 and 1 lakh. the scale of these values will be between 20,000 and 1 lakh. Let's take two data points, 50, 45,000 sal, 59, 45,100 sal. How to plot this data? We already discussed this concept in our first classes, so please watch those videos and come back here. How to plot this data? We are given two features, age and salary. Age is taken as x-axis, salary is considered as y-axis. 50, 45,000, this is the data point. 59, 45,100, this is the data point. This is how we plot the data. If we want to calculate the distance between these 2 points, what's the equation of distance, calculating distance between 2 points? It is square root of y2 minus y1 whole square plus x2 minus x1 whole square. y2 minus y1, 45,100 minus 45,000 means 100 whole square plus 59 minus 50, which is 9 whole square. So what is the distance? 10,000 plus 81. So observe here, the distance is affected by sal, because 10,000 plus 81, the distance value is getting affected by sal. Why the distance value is getting affected by sal? Because the scale of these values in thousands. The scale of these values are between 20 and 60, means hundreds. This scale is in thousands. That's why this scale of these values is large. That's why the distance is getting affected by sal. Means we are giving more importance to sal when calculating the distance, because the scale is different. Okay, now consider this, change this values to thousands. This 45,000 is written as 45 because we are not considering these values in rupees, we are considering this in thousands. 45,100 is written is 45.1. Now what's the difference? What's the distance between these two data points? 45.1 minus 45, which is 0.1, means 0.1 whole square, plus 59 minus 50, which is 9 whole square. So the effect of sal on distance is changed, because the scale of these values are changed. The scale changed from rupees to thousands. The scale has been changed. That's why the effect of this feature on calculating distance has changed. Means by considering different units, the effect is changing. We should not do like that. Why we are getting this problem? Because the values which consider are in different scale. Take this example, x 578, the scale is between is in tens, the scale is in thousands. Why we got this problem? Because we considered this in different units, here considered in meters, here considered in kilometers. By considering different units, we are getting change in scale of the values. So the problems which we face using numericals are based on scale. That's why we have to give equal importance to all the features. One should not get affected on the distance. So to do that, giving equal importance to all the features, we have to do what we have to do. We have to scale down these values to certain limit. Let's say the scale down these values to 0 and 1. Take this feature, convert these values to values between 0 and 1. Take this feature, convert these values to values between 0 and 1. Take this feature and convert these values to values between 0 and 1. Take this feature and convert the values to values between 0 and 1. Then all the numeric values are in the same scale. That is what scaling means. The problem which we face using numerical data is because these are considered in different units. That's why we are giving importance to one of the feature when calculating the distance. Why we are this much bothered about distance? Because most of the ML models are based on distance. We already discussed about our first model. What is that model? Linear regression model. We calculated the loss in that model. So please watch the videos and come back here. We calculated the loss. The loss is dependent on distance. Okay, that's why most of the models are based on distance. We should not give importance to one feature. So that's why numerical features are converted, scaled down to 0 and 1. This is one of the way. There are so many ways to scale down. Mostly used are min-max scaling, normalizing and standardizing. In this class we will discuss about min-max scaling. Min-max scaling is a method that scale down the numeric values to values between 0 and 1. Let's understand how min-max scaling works. Let's consider this example. 5, 7, 8. Take this column. What's the minimum value in this column? 5 is the minimum value, 8 is the maximum value. Okay? So this is the equation for min-max scaling. Minimum is 5, maximum is 8 minus 5. So now convert the values using this equation. Xi means consider the first value. Xi. 5 minus 5 divided by 8 minus 5. 5 minus 5 means 0 divided by anything is 0. So this value is converted to 0. Let's take 7. 7 minus 5 which is 2 divided by 8 minus 5 which is 3. 2 by 3 means what's the value we get? 0.66. Let's take the next value. 8 minus 5 divided by 8 minus 5 which is 1. We got the value 1. So what we observed here, the minimum value is given 0, the maximum value is given 1, and the remaining values which are between minimum and maximum, we are giving the values between 0 and 1. So we scaled down these values to values between 0 and 1. The same way, consider the minimum value is this, maximum value is this. 8,000, 5,000, 5,000. What's the first value? 5,000 minus 5,000 which is 0. 7,000 minus 5,000, 2,000 divided by 8,000 minus 5,000, 3,000, zeros, cancel the zeros. So 2,000 divided by 3,000. We got the same value. You observe it, 0.66. Again 8,000 minus 5,000 divided by 8,000 minus 5,000 which is 1. So we scale these values to values between 0 and 1. This is what scaling means. The same way, scale down these values to values between 0 and 1. Scale down these values to values between 0 and 1. This is what min-max scaling do. So min-max scaling assign values between 0 and 1. We scale down the values to values between 0 and 1. So next how we do this in Python? Understand the code, how min-max scaling works in Python. The min-max scaling class is present in from sklearn.preprocessing. This is the package. From this package, import min-max scaler. This is a class which we use to convert, which this class is works as min-max scaling. Let's take a data. Data is taken in a two-dimensional list. That is a list within a list. This is basic Python. Hope that you already know Python. That's why I'm going it little fast. Two-dimensional lists are similar to two-dimensional arrays in our C language. So two-dimensional list can be given like this: -1, 2, -0.5, 6, 0, 10, 1, 8. So how many columns we have here? First column, second column. So what's our min-max scaling do? Take the first column, convert these values to values between 0 and 1. How they will converted? Take the minimum value, take the maximum value and apply this equation. The same way, take the second column, minimum value, maximum value, convert these values to values between 0 and 1 using this equation. This is what min-max scaling do. So what's this class do is min-max scaling. How to use this class? Min-max scalar of is assigned to a variable called scalar. Okay, we assign this variable. Now we can use this variable as a class called min-max scalar. So in this min-max scalar we are having a function called fit, scalar.fit on data. What's the data? This is the data. What's the fit function do? What's the fit function do is, when we use fit function, it will identify how many columns are there in this data and identify the minimum value, maximum value, minimum value, maximum value. That is what fit function do. What fit function do is, fit function fit on this min-max scaling. What's fit means? The required calculations are done, means it check all this column and it will identify the minimum value, it will identify the maximum. It will check all this column and it will identify the minimum value and maximum value. That is what fit function do. What's the next one is print scalar dot transform of. What's the transform function do? After doing the fit function, what's happening? They identified the minimum value and maximum value. Minimum value and maximum value. Now transform those values, means convert those values to values between 0 and 1. At this stage, transformation is done. Okay, now we are displaying these transformed values. The values are like this: 0, 0.25, 0.5 and 1, 0, 0.25, 0.5 and 1. Okay, every value is converted to values between 0 and 1. Minimum value is converted to 0 and maximum value is converted to 1, and remaining values will be between 0 and 1. Hope you understand the concept. If you have any questions, please post your questions. And now let's check this coding in our system and we'll execute this code in our system. Okay,
coming to our code, this is our code. The link to download this coding document is provided in the description below. Here, from scalar.preprocessing import min-max scalar, data is equal to taken in list within the list. Scalar is equal to min-max scalar of, means we are assigning this class to a variable. From the class we are calling a function called fit is a function, which we already discussed this, what fit function will do. After fitting the data on this function, using this function, then you can transform the data. At the transformation stage, by calling this function, then only transformation will be done. So after doing the transformation, we are displaying it using the statement called print statement. Let's execute this statement, execute this code. So we got this output 0, 0.25, 0.5, 1. This is the first column, and the second column is 0, 0.25 and 0.5 and 1. This is the second column. So this is how we use min-max scaling. We use this min-max scaling in our real-time data sets. After completion of the min-max scaling, normalization and standardizing, we will use this min-max scaling to convert our real-time data, numerical data. So please follow this and we'll use this in our later sections. Thank you. Thanks for watching, and if you haven't subscribed to our channel, please subscribe to our channel. If you have any questions regarding the concept, please post your questions in the comment section below. Thank you.